given by x equal to 12t squared. Okay, so that's its position. X is going to be in meters, t is going to be in seconds. We're in regular standard SI units. For part A, it wants you to calculate the average velocity of the car between 2.15 seconds and 3.1 seconds. So remember, for average velocity, or V average, we'll have the change in x over the change in t. So change in x is always going to be the final position minus the initial position. You might see that as an O instead of an I, just for not, meaning where it started or began. Here it's just initial, an I for initial. Okay. Same with time. We'll have a final time, oops, and we're going to minus, not an equal sign, a minus the initial time, or the beginning time. Okay, and that's how you find your V average. Of course, the x's are going to be in meters, and the time is going to be in seconds, so your units are going to be meters per second. All right, so that's how we find V average. Now, how do we get these values in here? Well, I want to calculate what the average velocity of the car is between these 2 seconds. So I've got these 2 seconds down here. Okay, so I'm going to put V average is equal to, and I'll just fill out the bottom half. Now, the end time, of course, is going to be 3.1 seconds. Okay, and the beginning time, we started at 2.15 seconds, so it'll be 3.1 minus 2.15. Okay. As for the x, final and initial, we need to look at the equation, okay, to determine what x is at those times. So for x final, I can put x final is going to be equal to 12 times t squared. What is t at final? Well, t final is 3.1, so 3.1. And that'll get squared. Okay, let's plug that into the calculator quick here. We have 12 times 3.1 squared, or you could take it times 3.1 twice, and we get that this is 115.32. That's our XF, so that gets put over here. 115.32 minus, now we do the same thing for x initial. X initial is equal to 12 times t squared. What is t in the initial state? Initially, t is going to be ti. Ti is going to be 2.15. 2.15, don't forget to square it. We'll determine what this one is. Okay, do the same scenario. And for this, we should get 55.47. Okay, and both of these, being that they're x positions, they'll be in meters. Okay, they'll be in meters there. So then we can go ahead and put this one in over here. We'll have 55.47. Okay, and then we just have to calculate what this is. Okay, so the V average, okay, in this case, will just be that. Okay, if we do it out correctly, we should get 63 meters per second. Okay, I'll leave it up to you to get your 2 numbers up top here. We should get 63 meters per second. That's part A. Okay. For part B, we want to find out what the instant velocity is. So instantaneous velocity means that we're going to have to do a derivative. Okay, so remember in class when we talked about the difference between an average and instant. Average is over 2 different points, and instant means that you knock that that area into infinitesimally small spaces, and it gives you a instant velocity for that, where there's a negligible amount of change in time. Okay, so for doing this, we're going to need to take a derivative of this. So I have x is equal to 12t squared. Now I know that velocity, instant velocity, which we're just going to call v, okay, is equal to dx dt. Okay, that's our derivative. So which means I need d dt of x. X is this, so plunge in 12t squared. Now I'm taking a derivative of this with respect to t. Okay, so this is a power, so we're going to use power rule on here. Power rule, which we went over in class, just means that this upper number needs to come down in front. Okay, so if I was to do the derivative on this upper power on the t, because that's the term that we're taking the derivative to, the t up here has a 2, so the 2 comes down. So we're going to have a 2 times 12 times t, and now this number, being we brought it down, needs to minus 1. So this will be t. This will be 2 minus 1, or just the first power. Now you can write the first power there if you want. Most of the time it's not needed. You assume that everything is to the first power because that's just the number. It's just itself. Okay, so to finish this out, to write it out properly, we would have 2 times 12 times t, so we'd have 24t is going to be our velocity. Okay, that's how we get to the instantaneous velocity. The instantaneous velocity is now equal to 24t. So when we come back up and it says find the instant velocity at time of 1.5 seconds, all we need to do is punch in 1.5 seconds there. Okay. You also might see it written out as v sub t. That just means velocity in terms of t, okay, or with respect to t. So it would be 24t, which means our velocity when t is equal to 1.5 would just be equal to 24 times 1.5. Okay, 24 times 1.5, that you might be able to just do it right in your head. That is going to be 36. Okay, 24 times 1.5 is 36. Our units, their velocity, it's meters per second is how we got the derivative.